Hi guys, hope everyone is doing well. Today we are going to be talking about the areas of rectangles, part 1. This coordinates with chapter 13, lesson 6 in your MyMath book, which is starting on page 785. So I started out with a word problem, but before we even review that, I want to go over that area has square units unless it has a unit of measurement tied along with it. So just keep that in mind. It's a square unit unless it has a specific unit of measurement. So Jacob and Michael were planting a garden. They knew it was 4 feet wide and 7 feet tall. What is the area of the garden? So if I were with you, I would ask you, what's our first step for every word problem? And you would say, hopefully you said box out the numbers. We're going to box out 4 feet wide and 7 feet tall. Then I would ask you, what do you underline? And you would say, hopefully you said the question. So what is the area of the garden? So we know if it's 4 feet wide, that means we're going to have 4 columns because our width is the top and the bottom. And it's 7 feet tall, so we're going to have 7 on each side. 2, 3, 4, 5, 6, 7. So if we were doing perimeter, we would need all the numbers on the outside, but because we're doing area, we only need 2. So I'm going to go ahead and erase those because we don't need them. We just need the 1 and the 2. Now, if you're doing area, you can count all the squares inside. You can skip count the squares, or you can multiply. Miss Wall's going to multiply. So if I do 7 times 4, I would get what? Let's skip count by 7. So if I said, hey class, 7, 14, 20, 1, 28, what's my 4th finger? So it'd be 28 feet. Again, it's not square units, it's feet because it says feet in our problem. So that is how you would find the area of a rectangle. But you guys will also see on page 786, there are a couple other problems where you have the rectangle given to you, and then maybe it has like a 9 here and a 2 here. But rather than it having all the squares inside, it has these 4 squares in the corners. Now, I know that it's different than what you're used to seeing, but I don't want it to confuse you. These squares don't mean squares like in a row or in a column. These squares mean that the angle is a right angle. We didn't get to talk about those too much before y'all left, but remember we talked about an acute angle is less than 90 degrees, and it's oh so cute. So it's acute, and then you have a right angle, just like a corner, like of a room, and then you have an obtuse angle, which is larger than 90 degrees. It's a bigger turn. So these 4 corners don't mean tiles in a square like the problem I previously showed you. They just mean it's a right angle. So if you were to solve this problem, you could do it multiple ways. You could do multiplication. 9 times 2 equals our unknown. You could add 9 2 times. 9 plus 9 equals our unknown. You could add 2 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9 equals your unknown. So those are the 3 ways that I want you to solve it. Either multiplication, and you can use the commutative property, which would switch those to 2 times 9 equals your unknown. Either way is fine. If you want to do this way or this way, and then 9 plus 9, or 2 added 9 times. Hope that helps, and if you need more help, go on to part 2.